Today we are going to be dealing with pseudocodes and flowcharts. We'll start with the 2016 paper 2 question that came, then we'll go to 2017, 2018, and that is where we are going to end. However, you should watch out for the rest of the other questions being answered from 19 and also the 2020 paper. Okay, so we are looking at question 3 in the 2016 internal paper, question 3A. Question 3A says the program below is given in the form of a pseudocode. So there is start, enter radius. If radius is 0, then display error message and re-enter the positive radius, else enter height. If height is less than 0, then display error message and re-enter positive height, else volume is equal to 1/3 times pi times square radius times height, and if display volume, then stop. The question is, draw the corresponding flowchart for the information given above. Draw the corresponding flowchart for the information given above. So quickly, just to start, let's do a quick recap. So what we have learned is you have this shape, the oval. The oval represents start or stop. Start or stop. The oval represents start or stop. Then we have a parallelogram which represents input or output. Then we have a rhombus which represents decision. We call it a decision box rather. And then you have a rectangle. A rectangle represents process. Apart from the rectangle representing process, we have the arrows. The arrows show direction of flow. They show direction of flow. So that is just a quick recap that I thought we should have so that we know the shapes, the objects that we are going to use in order for us to be able to construct our flowcharts. So let's begin. The question says start. So when it says start, you are going to draw the shape for start. You will say start there. The second step we've been told enter radius. So you indicate using an arrow showing that you are going down. Then we've been told enter radius. Enter radius, it's an input, meaning we need that kind of a box. So bring that in place. After you do that, you put enter R. for enter radius. You indicate the flow in that way. The first step says start, second step says enter radius, the third code that we have there is if radius is less than 0. So the if statement is a decision, so we need to introduce a decision box. So at this particular time we introduce a decision box. So the decision box should say is r less than 0, is r less than 0. If yes, the first one will say this is yes, and this should be represented with no. If yes, then display error message and re-enter positive value. So if yes, it should take you to the display. If you say display is an output, so you introduce that box again for output. Introduce that output box, and in the output box you say error. Then H must be positive. Okay, error H must be positive, which means you have to go back now. So where do you go back? You go back all the way up and you go and join that arrow again. You go up, you go and join that arrow. You are going back so that once you connect to that flow, it should bring you back to entering the value of R, so that you can now put the positive value of R. Pardon me, that should be R there, not H. That should be R while dealing with radius. The radius must be positive. Okay, so now we are done with the yes part. Let's come to no. Okay, so R must be positive. So we've gone back up there. We enter R now. Is R less than 0? Is R less than 0? No. The no part, what do they say if no part? That's what is represented by else enter height. So if it is no, it means you go down now and you introduce another input box and you are entering height. So you say enter H. You enter H there. Then you continue the flow. You enter H. Then we are told, then if H is less than 0, if height is less than 0, if height is less than 0. So we have the if statement again. So it means we introduce another decision box right there. And in that decision box, what we are saying is H less than 0? Again, if yes, then display error message. So if it's yes, it takes us back again to the display, and we say display error message. It should say error again. Then it should indicate H must be positive. and then it takes you back to the point where you were entering the value of h. So it takes you back there, the flow takes you back there. Once you join back here, you have to re-enter h, so that this time the h can be a positive value. Then if no, this will be the no part. It is indicated by else. Volume is equal to 1/3 times square radius times height. So what we do there is, else they've given us a formula, which means it's a process. So formula is for processor. We introduce a processing box, and in that box we tell them volume is equal to 1/3 pi times r times h. Once the process has been done, we come down and then it says end if display volume. So meaning after the process we need a display box there to display volume. So in the output box I was just saying display volume. Display volume. Once volume has been displayed, then end. Since we started with start, so meaning we should not say end, but instead we should write stop. 2017 paper 2, internal paper, question number 6. So what we are dealing with. The question reads, study the flow chart below. So the flow chart that we're able to see is the flow chart under consideration there. So it has start, then enter r. Is r less than 0? If yes, then error. It should display error. R must be positive. If no, then process area is equal to 1/2 times r times sine theta. Then display area, then stop. The question is, write the pseudo code corresponding to the flowchart above. Write a pseudo code corresponding to the flowchart above. So in response to question number 6, as our answer there, we are going to, the first thing that we do is to write start. So the first circle, the oval there tells us it starts. Then the second box, we're able to see that that is an input box. So we say enter radius. Enter radius. Because the flow chart is telling us enter r, so the r is for radius. Enter radius. Immediately after we indicate enter radius, we have a decision box there telling us that is r less than 0. So our instruction should be if radius is less than 0. So we are going to indicate if radius is less than 0, then display error message. Display error message. display error message. Then going to the no, following the arrow for no, that should be represented by else. Else, you continue there by saying else. Else, our process area is equal to, you can write the word info, area is equal to 1/2 times radius times sine theta. Having done that, then you say and if display area. Then you say stop. Then you're done. You're home and dry. The pseudocode of the program would have been written correctly. Straight away now, we'll move on to start looking at the pseudocode and flowchart question that came in the GCE paper for 2017. Now we are looking at 2017 GCE paper 2 question, which was under the pseudocode and flowcharts. It was question 6b. Now go ahead and read the question. The program below is given in the form of a flowchart. That's the flowchart that we're able to see on the screen. That's the flowchart. Take a good look at the flowchart, understand it, look at what is there. So I'll quickly read it. It has start, then enter A, R, is R less than 1. If no, you go to the very end. If yes, sum to infinity equals A over 1 minus R, then display sum to infinity, then stop. What is the question requesting from us? The question says, write a pseudocode corresponding to the flowchart diagram above. Write a pseudocode corresponding to the flowchart diagram program above. So 6b. So 6b. Just first things first, start. Our second box is the input box, so it's obvious, you just say enter. A, R. Then we have a decision box. Because it's a decision box, you start with if. So you say right, pardon me, should be 1 there. Then sum to infinity equals else then sum to infinity, that's if it is yes, then else is for that's if it's no. Else and if display. Then the last thing should be stop. That was how you are supposed to write the pseudocode. Now we're looking at 2018 paper 2 internal, and the question under pseudocode and flowcharts came as question number 6b, and the question reads: the program below is given in pseudocode. And I'll read the pseudocode there. Start, then enter xy. Next step, let m be equal to square root, open bracket, x squared plus y squared, close bracket. Next step, if m is less than 0, then display error message, m must be positive. Else, and if display m, then stop. The question reads: draw the corresponding flowchart for the information given above. Draw the corresponding flowchart for the information given above. Straight away, we know the first thing first, we go with start. So we introduce that shape there and we say start. Follow the flow, and next thing should be our enter box there, or rather our input box, and we've been told enter x, enter y. So we're just going to do that. We're going to say enter x, comma, enter y. After we do that, the next thing that required was that let m be equal to square root, open bracket, x squared plus y squared. So what we do is we take it down there, and we're going to introduce a process. It's a formula, so it should be in the processing box. So we do our processing box in that way, and we say m is equal to, open bracket, x squared plus y squared, close. So let's not forget you said square root, so we indicate our square root in that way. Say square root, then x squared plus y squared. So m there, square root, x squared plus y squared. Okay, in that way. Then the next step, we continue the flow there. It says if m is less than 0, so they've said if it's a decision, So we introduce the decision box at that point, and then we say is m less than 0? Is m less than 0? If yes, then display error message m must be positive. So if yes, you have to display an error message. So the output box is that one. You can create the output box or the display box. It's the same as the box for enter. So in that box you say error. When you say error, you're going to tell them m must be positive. M must be positive. So as of now, we are going to end it there, but follow me closely. We are going to complete it properly in some way. So now let's go to the second part. That it says else is for no. Else we introduce display m, display box there. So we say display m. Formula has already been entered. If that is there, you got to know, then you display m at that particular point. After you display m, it says else display m, then end if. So end if display m, it's there. So after you've displayed m, what should come next is stop. Stop or end. So remember this, they just told us in the pseudocode that if m is less than 0 and it's yes, then you have to display error message. They didn't say go back this side. You go back to input m again. See, because they didn't say that, maybe leaving it like that, it might be a little bit hanging. So what you do, you just bring it down, then you send it there, so that it joins that flow and it stops with an error message as a display. That's our flowchart for 2018 Paper 2 Internal Question 6B. Follow me closely as we do our last question under pseudocodes and flowcharts. 2018 GCE Paper 2, Question 5B. I read ahead of you. Follow closely on the screen. You're able to see the pseudocode that is there. And I read the pseudocode now. Starts. Then enter A, R, and N. R is equal to 1 minus R. If capital R is equal to 0, then print the value of R is not valid. Else sum or Sn is equal to A open bracket 1 minus R to the power n close bracket over capital R. And if print Sn, then stop. The question reads, construct a flowchart corresponding to the pseudocode above. Construct a flowchart corresponding to the pseudocode above. So we are constructing a flowchart. So straight away go ahead and start. Start. They told us enter ARN. So say our enter box there, our input box, and we'll say enter A R N. Next, they've told us R is equal to 1 minus small letter r. So which means here we have a process, because they gave us a formula. We said capital R is equal to 1 minus small letter r. Then if capital R is equal to 0, so meaning we have a decision box, so we do our decision box there. And in our decision box we are saying is R less than 0. Is R less than 0? Then print. So the moment you see then, it means that was a yes. So the yes. Then print. So if they say print, print and display is the same thing. So it means you introduce an output box or the display box there, and say then print the value of R is not valid. The value of R is not valid. Which means you have to go back up again and go and re-enter in that way. Else means no, it was for no. Else, the flow is going in that direction. Else, Sn is equal to that. So they've given us a formula, meaning we bring back the process box again, a rectangle. In the process box, we enter our formula. Sn is equal to so we've now filled in our processing box. We have filled in Sn is equal to A open bracket 1 minus R to the power n close over 1 minus R. And as I was saying that we've put 1 minus R there because this is the value of the capital R. So we can either put that R, or you can simply put that to represent R. It's one and the same thing. And then we are told that once you do that, end if print Sn. So end if print Sn. So we continue the flow there, and we say this our output box, and in our output box we are saying display Sn. After displaying Sn, then stop. Stop. Alright, that will be it. Then you stop there. If you do that, again I repeat, you will be given 5 marks for doing that. You would get all the 4 marks, as this would have been the correct way that you are expected to respond to a question, to this question in particular, and to any other question which will come in this particular way. Yeah.